So, how many phases of investigation are possible during investigating an OOS result? So, there are three investigation phases possible: the phase 1, phase 2, and phase 3. So, as a part of this video, we will talk about how one can conduct phase 1 investigation. So, if you go through MHRA presentation about the OOS investigation, you will find that MHRA has defined phase 1 investigation into two parts, that is in phase 1A and then phase 1B. But if you look at the US FDA guidance on OOS investigation, then you will only find phase 1 investigation. FDA has not further classified either phase 1A or phase 1B. But if you look at the content of MHRA and content of US FDA guidance, you will find they are almost similar. So let us begin with our talk on how one can undertake phase 1 investigation during an OS investigation. So as I said that according to the MHRA, phase 1 investigation is further divided into two, that is phase 1A and phase 1B. So what is the purpose of phase 1A investigation? The purpose of phase 1 investigation is to determine whether there has been a clear obvious error. So what you are going to determine as a part of phase 1A investigation? Obvious error. You will determine whether there is any obvious error occurred during this particular OS. As a part of phase 1B, and remember, you cannot parallelly run phase 1A and phase 1B investigation. You need to first conclude whether there is a phase 1A investigation error, that is, whether there is an obvious error available or not. In case if there is no obvious error identified, then you can go for the phase 1B investigation. So what you are supposed to do as a part of phase 1B investigation, you supposed to identify whether there is any assignable cause associated with the reported out of the spec result. Now there are two important terms. One is obvious error as a part of phase 1A investigation, and the second term is assignable cause as a part of phase 1B investigation. So we broadly understand what is the purpose of phase 1A investigation and what is the purpose of phase 1B investigation. Let us now further understand in detail what is really meaning of the obvious error or what is meaning of the assignable cause. Now this is very important. So as a part of phase 1A, we are going to talk about the what is the meaning of obvious error. Let me rearrange the presentation and here we go. So an error resulting in an OS result which is detectable by direct evidences. That means what are the errors that can be detected directly? Those are called as obvious error. So does it make sense to investigate directly detectable error as a part of your investigation? Certainly yes. So that is the reason the MHRA said that you first target whether there are any errors which can be detected very easily. And they just call all of such errors as an obvious error. What is the assignable cause? Assignable cause is nothing but a scientifically justified explanation of the reason for an OS. Scientifically justified. So, to justify something scientifically, do we need to conduct scientific experiment? Absolutely yes. So, the assignable cause can only be identified after conducting some scientific experiment, or they must be based on some scientific experiment. So, the assignable cause may not be detected very easily. Why? Because they have to be justified after conducting some number of experiment and they may be little deep down, not on the surface, not easily detectable. So in roughly, you can understand that obvious errors are easily detectable and assignable causes are not easily detectable. They need to conduct some number of scientific experiment, and based on the scientific ground you will say, okay, now this is the error, and as I conducted some amount of experiment, I will recognized this error as a assignable cause. So I hope you understand first the difference between obvious error and the assignable cause. Phase 1A means determination of an obvious error. Phase 1B means determination of an assignable cause. Now, what are the example of obvious error? And I think it is also it makes a lot of sense why one has to first identify the obvious error and why not the assignable cause at very first time. So let us now understand what are the examples of obvious errors. What are the examples of the obvious errors? And there are few examples which are again mentioned into the MHRA guidelines. That is calculation error. Will the calculation error be easily detected? Is it first detectable error? Type yes or no in the comment box below. Calculation error can be easily verified. So rather than going deep in the investigation, first let us understand what is the calculation, whether the calculation has done accurately or not. So this becomes the obvious error. Then power outage. Identify whether there is any sign of power outage. Equipment failure. Now, can equipment failure be easily detected? Let us say there is a column leakage. You can easily detect the column leakage during the chromatographic analysis, HPLC analysis. Testing errors like sample spillage, can it be detected easily or not? Incomplete transfer of sample, it can detect very easily. Incorrect instrument parameters, for example, the detector wavelength in case of HPLC UV analysis. So all these errors comes under the obvious errors example. So do you have any another example of obvious error? If yes, please do let me know in the comment box below. So once you have started with the phase 1A investigation, you're supposed to understand the obvious errors. And these are the few examples we discussed related to an obvious error. Now, if obvious error identified, suppose you and your supervisor have undertaken the investigation and you found that okay, now there is some obvious error identified. So what is the intention now? Take appropriate corrective action. Take appropriate corrective action and conduct repeat testing if required to confirm that the error is corrected. What is meant by repeat testing? Let me first explain you. Repeat and the testing. So see, as a part of analysis, you have prepared some solution, maybe stress solution, maybe standard solution, and this solution should be available on the bench. You should not throw out the solution after the analysis gets over, right? So you have to preserve the solution until the confirmation of the final result. So you have the retained solution on the bench and the solutions are stable. So whatever testing you are going to conduct as a part of or by using that available the available solution, that is called as a repeat testing. I repeat one more time, the repeat testing means the analysis conducted by using the available solution on the bench. For example, uh, you have a standard stock solution. You have a standard stock solution available on the bench, and as a part of standard preparation you are diluting 5 ml of the standard stock to 100 ml, isn't it? But as a part of investigation, what you found that there is incomplete transfer of a standard solution. Instead of 5 ml pipette, you have used 4 ml, which can be detected very easily because on yours at your work area, there is no 5 ml pipette found, but there is a 4 ml pipette found. So is this the evidence that the transfer error must have been occurred during preparation of standard solution now? Because instead of 5 ml you are holding 4 ml pipette, so you have doubt that okay, I must have used 4 ml pipette. and this must have resulted into an OS result, for example. So what you are going to do as a part of repeat testing to confirm the error. So you have a stock solution on the bench, yes or no? Now purposefully again you will pipette 4 ml of the stock and dilute it to 100 ml to prepare your standard solution. Now which is what? Just confirming if I really make 4 ml dilution, do I get the OS result again? You can compare the standard area of your original analysis and this time. And again you will pipette out 5 ml, which is actually required as per STP, and then you confirm whether you are meeting the specification or not. So this is called as what? Repeat testing conducted by available standard stock solution. So once you confirm that, okay, now the error is identified and confirmed, then you can go for retesting by the original analyst if no error associated with the analyst is found or no analyst error is found. See, here is the catch important point. Conduct retesting. Let me first explain you what is meant by retesting. So in the same example, we said that now the standard solution prepared wrong. And you said that, okay, as a part of investigation during repeat testing, I also pipetted 5 ml and found result meeting the spec. For example, assay. Can you consider the analysis conducted during the repeat testing? Certainly not, because that was your part of hypothesis and the investigation, and that result need not to be reported as a final result. You need to again conduct the fresh preparation of the standard, right? Fresh preparation of the test, and that analysis will be now called as what? Retesting. So you are going to make all the solution fresh newly. Now the question will be, who has to retest sample? Can original analyst retest the sample? Certainly yes, provided as a part of investigation that original analyst should not be at the fault, means there should not be an evidence of analyst error. In that case, you cannot perform the analyst by original analyst. But in case if there is no analyst error found, if there is no analyst at the fault, then you can ask original analyst to conduct the retesting. And sometimes even if it is not necessary to conduct the retesting also. Let us say there is an calculation error found. Are you going to ask the analyst to repeat the or retest the sample one more time? Certainly not. You will just correct the calculation error and say that, okay, look at here now. This was the obvious error identified. Instead of correct potency, analysts have used wrong potency for the standard, and that has resulted into a OS result. But when we put the actual potency, then the result is within the spec. In that situation, even retesting and repeat testing are not necessary. So I hope you understand how the investigation of phase 1A can be conducted. Now, as a part of this investigation, if the no error is identified, means if no obvious error is identified, so what are you going to do? So you are certainly going to now go for the phase 1B investigation. 1B. After 1A, 1B comes, and we discussed that as a part of 1B investigation, you are going to determine what? Assignable cause, right? The scientifically justified reason for the out of specification result. So let me just briefly walk you through the phase 1B. Phase 1B means what? To identify the assignable cause. What is assignable cause? A scientifically justified explanation of the OS result. So as a part of this 1B investigation or phase 1B investigation, you need to build some hypothesis. Now, what is the reason for this out of the spec? What kind of errors will result into this out of the spec result? You have to think yourself first, right? Based on to your experience. You need to form a team of the expert, and this team will have the brainstorming sessions. They will discuss, okay, now what could be the reason for this kind of errors? And then the team will build certain hypotheses. Hypothesis will allow you to conduct some scientific experiment. But why hypothesis? Hypothesis, why means what? To confirm or discount a possible root cause. Either your hypothesis can be wrong, or it can be right. If it proved to be right, then you say, okay, it is confirmed now. Because of this, the OS result occurred. If it is wrong, then certainly you are going to say, look at here now, this is not the reason for the out of the spec results. You are going to discount that particular reason. So how the hypothesis has to be conducted is very important. And these are the points that we are going to talk as a part of this hypothesis building. The first and foremost, ask this question, what might have went wrong? Because you are in the process of understanding the root cause or the error. Hypothesis testing must always be defined in a pre-approved protocol. Okay, this is very important. You cannot have the hypothesis built in the morning and then as a part of your thinking process, you will say, no, no, this experiment is not required. Let us do little differently. You have to document all the hypotheses as a part of the protocol and you need to execute them according to it. Should be well planned and scientifically sound. Certainly must be scientifically sound. Must avoid inappropriate ad hoc testing. Now, ad hoc testing means what? Testing, impulsive testing. Okay, no, I don't think so. This could be the reason. I have not thought about this point during the brainstorming session while team discussion, but right now I am thinking this could be the reason. So, can we plan this experiment? This is called as the ad hoc testing. So, this impulsive testing must be avoided as it is inappropriate. You can conduct those testing, but it has to be documented and then you can go for the testing, but not impulsively just as you are thinking this could be the reason, right? Must avoid taste into specification or the compliance. Now this is the very important point. You need to avoid yourself in testing into a specification or compliance. The intention should not to understand what changes are needed to meet the specification. That is the testing into compliance or the specification. That has to be certainly avoided. The results from hypothesis testing must only be used to confirm or discount a root cause. And now this is the very purpose of the hypothesis testing. This cannot be used to replace your original result. They cannot replace the original OS result and you cannot report them as a final result. So I have a few guidance on you on conducting the hypothesis testing in case of chromatographic testing, like let us say an HPLC method. So read-diet FM is the formula and you can use that formula. So let me explain you what is meant by read-diet FM formula. So the first one is what? Okay, so let me put it here now. Re and then the D. So D stands for the dilution. I hope you understand the re-dilution connection. So incomplete transfer is suspected. Yes, then you can go for the re-dilution. The way I explained in the first example during obvious error. Re-injection. Are you doubting that there is something transient equipment malfunction suspected? There is air bubble found probably during the injection of the sample and has resulted into the lower area and hence this transient equipment malfunction is suspected, or for some reason the amount of injection volume is low during the injection of the sample solution. Re-extraction means what? You are using the extraction techniques like sonication or shaking, but you have a doubt that the sonicator probably was not working well, or analyst might have sonicated the sample for lower time, which has resulted into the lower assay result. So extraction was not done properly. You have a doubt about that. So conduct the re-extraction experiment. You can conduct the re-extraction experiment. The first one is what? T stands for the retest. Now here is a caution. Retest is not generally permitted or allowed during investigation or confirmatory testing of the root cause. It only can be conducted as a part of once you confirm the root cause and then you want to generate the value to report the value, then you can conduct the retesting. But as a part of investigation, retesting is not allowed. But then why I am saying the retesting can also be part of hypothesis. Look at here now. It is only applicable and allowed if the solution itself is unstable. See, to conduct the repeat testing, you need to have a stable solutions. isn't it? If the solutions are unstable, can you use them? Certainly not. So you have a solid point to say that now the solutions are unstable, I cannot do the repeat testing, and hence I need to conduct the retesting in the context of investigation. In case if the wrong stock solution was prepared, let us say you're supposed to take 40 milligram of this weight, but you have taken 140 milligram of the weight. I'm giving very vague example. So weight is strong. So how you can use that stock for the further investigation? Certainly not. The stock with non-homogeneous sample. So in case if you are preparing the sample solution, but you have doubt that probably the sample is itself not homogeneous. So if the sample is not homogeneous, if it is heterogeneous, how that result can be considered for the reporting? The flask used for stock is contaminated. Look at here now. You are using the stock solution for, let us say, preparation of the repeat testing. But if the stock solution itself is contaminated because of the contaminated flask, can you use that solution anymore now? Certainly not. And hence you can use the retest for the investigation. And last but not the least, use of wrong chemicals for the stock preparation. I hope you can resonate with my thought process when the retesting during investigation is also possible. So the T stands for the retest, and then F stands for the refiltration. So if you are thinking probably the filtration process is not followed correctly or the wrong filter paper is used, then you can think of conducting the refiltration experiment. And the M stand for the malfunction. So potential equipment malfunction. Any related to the instrument failure is M, malfunctioning of the performance of the equipment. So the M can be the part of your investigation. So REDITE FM is the formula to conduct an hypothesis for an chromatographic test procedures. Now, as a part of this investigation, there are two possibilities. If assignable cause identified, what you are going to do? Hmm? If assignable cause is identified, then certainly take appropriate corrective action and conduct repeat testing if required to confirm that the error is corrected. I hope you remember the repeat testing discussion during our first session, phase 1A investigation. And if you say that now the error is corrected, then go for retesting, right? Maybe by same analyst, that is original analyst, provided that the if no analyst error was found, and then omit the assignable cause. Take utmost precaution so that you are not going to have the similar kind of errors during the retesting now. So repeat testing followed by retesting can be done in case if the assignable cause is identified. But in case if there is no assignable cause identified, go for the phase 2 investigation. The phase 2 investigation is called as the full scale investigation, where only not laboratory people will be involved now, but manufacturing people, vendors, they will also jump into the investigation process now. So you need to again keep on investigation the possible lab error even as a part of the phase 2 investigation. So I hope you must have got an overview on how the investigation, at least during the phase 1 has to be conducted if you come across out of the specification lab result. My name is Bhaskar Napte and I am on the mission, to provide the absolute clarity on all technical aspect as possible, and that's the reason I share my knowledge with the community. In case if you are struggling with such kind of technical information, or if you want to have the more information about all the technical aspect, do consider joining the Pharma Growth Hub. So there is a link given in the description. Please click on the link and join the team and understand what are the benefits, how this platform can help you. Thank you so much.